Hi, my name is Rogério da Silva, and I'll be showing you how to prepare for the ISTQB exam. This is the second section, so if you watch the first section, well done. So stick to the second section now. And this time around, I'll be talking about the testing throughout the software life cycle. And at the end of this section, as well as the same as the first section, I'll be having sharing some quiz, so you can practice about this section only, so it can help you fix on your memory what you learned so far. So hang in there and be prepared, because there's so much more videos that to come, and I hope you enjoy. And again, the videos are short versions, so you can go and you can always go back and look at the specific section. If you didn't understand, you can always drop a comment, question, or make any criticism about this section as well. That will help me improve it for you. So hang in there, let's go. Okay, guys, this is the beginning of the second section. So, what we will learn on this second section? So, on this second section, I'll be talking about the software test methodologies, like Waterfall, V-Model, and Iterative, like Agile. What is unit or component system testing? What is the integration part of the testing, the system testing, and the acceptance testing means, the differences between functional and non-functional testing, what is structural testing, change-related testing, and maintenance testing. Okay, life cycle models. So it is divided by ISTQB instructions is divided in two sections, which is a sequential life cycle models and iterative incremental, like agile type of life cycle models. In my experience, I have used the V model and the waterfall, and also agile as well. It depends on the project. But this will fall on the ISTQB exam as well, so pay attention on this one. So in the sequential life cycle models, the entire system is built in a single sequence of activities that successively define, build, test, and implement the software. The examples are waterfall, structured system and analysis and design method, the V model, and the DW model. There are others as well, but those are the more common ones. Iterative incremental agile life cycle models. In iterative incremental development models, systems are built in a series of short development cycles which deliver working systems in a number of separate increments that can later be integrated together. Agile development is a term for several methodologies, include Scrum, Crystal Clear, and many more. The most common one you see is Agile Scrum. Each has its specific approach, but all share the common vision and core values as a continuous planning, testing, integration for the project and software is adaptable, and that they all focus on empowering people to collaborate and make decisions together quickly and effectively. Again, it's still at the life cycle models, but just condensed a bit more into the actual names that you will see more often. Testing does not exist in isolation, so test activities are related to software development activities. Different development life cycle models methodologies need different approaches to testing. There are many system development life cycle models which fall into two main categories: the sequential, like I mentioned before, waterfall and V model, and iterative incremental agile. It's a rapid application development. It can be defined as a rational unified process, extreme programming, Scrum, dynamic system development method. So you see all these short names out there. The most common ones you hear, it's a waterfall, which is an old way of doing development, V model, and agile. Here's an example of a waterfall model. As you can see here, the shape is it's like a waterfall. So the life cycle through which a project goes, as sequential or linear design process, testing is carried out at the end. So that's it's not very ideal, as we mentioned on the first section that early stage testing is better than later stage. So it involves these sequence initiation, analysis, design, build, then test, then deploy. So this is the traditional approach to system development. Each stage is quite separate, carried out by specialists, and each must complete before the next begins. Each stage outputs the deliverable, which is input to the next. All testing is done at the end after the code is developed. Therefore, this model does not allow for early testing as recommended in the principles earlier. So a much more detailed V model. In this section, you can see a bit more in details each stage and how the static uh, side relates to the dynamic side from the beginning to the end of the delivered the product. So there are many variations of the model with slightly different numbers and description of levels. The ISTQB Foundation Exam Syllable refers to a model with 4 test levels, which is a component, integration, system, and acceptance. But you know, this in this section we're gonna show as well. We're gonna describe an extra level uh, in this demonstration. To describe the view model with 5 levels of testing instead. Component testing, component integration testing, system integration testing, acceptance testing. So basically, each side corresponds to the other side. So business requirements. So at the end of the acceptance test, the tester is gonna have to refer back to the business requirements and see those that matches the business requirement and so on. Here's a better representation of the V model. You can see it more detailed. Like I explained on the previous slides, each section of the static of the preparation of the specification is related to the testing side. So the first level is the user's requirement matches with the acceptance testing. So when the product is um, ready to release go public, it has to match the business requirements. Is it what the business want? So after the business requirement, the interface specifications is related to the system integration testing. The system specification, which is after the interface specification, because it matches with the system testing. So the testing correlates to that, and on and on. So the design specification, component integration testing, component specification, component testing. So you see, there's loads of static testing. There's a chance that as early as possible that the test is it's related to the requirements and the specifications. As soon as it jumps into these sections here, um, prior to the code area, when the developers start to code, is better because then you can help identify and raise questions like we tester do. We are championing asking questions, and that those questions can lead to a better improvement in this area, in this section. Once they start to code, then we can start to test, and then moving on to the dynamic testing where you're going to be more hands on deck, which is component testing, and then the component integration testing, and the system testing, the system integration testing, then finally the acceptance testing. So in furthermore, down the videos, you're gonna see more details, a bit more, all of those. This is the V model. It does have similarities with the sequential method, as in, in Waterfall. The V model includes a number of different test levels, each correspond to a development stage. You see, it begins with requirements, does the old is static, then coding, and then dynamic testing, and then the product is ready. So these method, I like this method as well because it allows your test activities to be fully integrated with the other tasks in the project life cycle. Mini cycles show the purpose of each test level and show the importance of catching defects early. The V-mode also shows how static testing can be carried out during the development stage before the code is written. So just before the coding area here, this section, I'll be explaining in more details in the next slide, is, it can help you identify before you start the coding, it can help you testing at the static, at the document level. And, it can help you identify earlier bugs and faults and error as early as possible. Okay, this is my favorite one, which is Agile. So iterative incremental Agile models. Software design model where the stages are going opposite to the waterfall method. Testing occurs as part of each sprint. So Agile development is an umbrella term for several iterative and incremental software development methodologies. The most popular Agile methodologies are Scrum, Crystal Clear, XP, which is Extreme Programming, DSDM, and FDD. So typically, development teams work closely together with fewer formal documents and more emphasis on face-to-face communication. This minimizes overall risk and allows the project to adapt to changes quickly. So I like that because it's more of based on your experience, and it's more exploratory and less documentation to go through, and also the fact that you are more interactive a lot more with each other and all the stakeholders involved on the development project. Here's an example of Agile. So the project is divided into tasks, and each task is divided into sprints, into a time box, into some places are 2 weeks sprints, and within these 2 weeks, you get the requirement of the development feature you're gonna develop, the design, and you get to code, and then while the code, and then you test, and then you test just these part of the feature decided that is going to be developed within these 2 weeks. So the team decides what they're going to do in this time length, in this time box. So I'm saying 2 weeks, but this is based on the experience on other projects, but it could be any more weeks or less weeks than that. This is the typical time length that most projects I worked with before. So and then what it does is once you developed a little bit within this time box, then you develop the next one. So you join them together, and then you develop the next one, and you increment and on and on and on until you get the whole package, the whole product developed. Now at the unit or component testing, test individual units or pieces of code for a system. The aim of Component testing is to determine whether an individual function works properly in isolation before integrate with the system, then combine it with other components. Component testing is different from all later test stages as it is not done by testers but by developers of the code in the developer's environment using IDE like IntelliJ, debugging tools and test frameworks incorporating stubs and drivers. As an example, in the V-model method, component specification component test level unit is where is allocated at. So if you remember the V-model I showed earlier, so the code review, then they do a code unit and then a bunch of code unit, which is small parts of a component. And then this component is ready for to be tested. Okay, once the unit becomes a component, and then various components it's started to join together, then we have the integration testing. So it's performed to ensure that two modules operate together correctly. The aim is to test all major interfaces and interactions between the individual components and to uncover communication failures between components. It should not test the functionality within the component, but this, by this time is already been done by the component testing. I showed that on the previous video. Only focus on how to communicate with each other. It is normally performed by developers in the development environment. So if you look back in the V-model document, the design specification component integration test, it shows which level it is. Right after the component integration testing, this is the system testing. So as you can see on this example, the system testing, it's the join together of the unit and the components, and after the components integrate to each other, then we test the system. Test the various parts of the application work together within a system work. This test the behavior of an end-to-end integrated system as defined by the scope of a development project. It is usually conducted by independent testers. System testing may include tests based on risks, requirements, business processes, user case, or high-level text descriptions, models or system behavior, interaction with the operational system, and system resources. The test environment should be as close to the production environment as possible in order to minimize the risk of environment-specific failure not being found in testing. So if you refer back to the V-model document, you can see these interaction or these key points on the system specification, the system testing. System integration testing. So once the system has its components ready, it will have to link with other systems. So it's most likely that the system will have to connect internally with other systems or other organizations externally. So the purpose of the system integration test is to expose defects in the interfaces and interactions between systems and between hardware and software. So it is normally carried out once the system test is complete by independent system testers in a near live environment, for example, like UAT. When testing links with external systems, testers may control only their own side of the interface, which might be considered as a risk, as the test systems may be linked to an external production system. So there are always boundaries around that. Workflow implementation of business process may involve a series of systems where cross-platforms uh, issues may be significant. So here's an example. So the system on the test has been developed, but you might connect with a legacy system, an old system. So there's a connection between them. There will be other current systems. There will be external connection with over the internet. So external systems or other database. There will be a database internally as well. So the tester will be testing all the boundaries, all the in and outs of the system on the test. In this part, we're talking about acceptance testing. Acceptance test is to determine whether the product indeed satisfies its specifications and user story requirements. The purpose of acceptance testing is to establish confidence, and main focus is ensuring it's fit for purpose, not finding defects. Acceptance can be carried out by real business users or by independent testers representing users. Acceptance testing is normally the final stage of testing before deployment. So in the V model document, you see that on the line on the first line on the static side, which is the business requirement, and then the last line on the V model, it's the acceptance testing. So in this stage as well, the acceptance testing as well, you hear UAT. UAT is another name, it's a user acceptance testing. So that can be also called as UAT. Okay, now we're talking about functional testing. Testing what the system does based on analysis of its specified requirements. Functional testing is concerned with what the system must do to achieve its objectives, as defined in business requirements, functional specifications, user cases, business process models, etc. It considers the external behavior of the software, hence is known as black box text testing. Functional testing is usually associated with data manipulation such as input, validation processing, storage, and output. This is as opposed to functional, there is a non-functional testing as well. It's a testing how well the system meets the required software characteristics such as performance and usability. It tests the attributes of a system that do not relate to functionality. It is concerned with how well a system works. It considers constraints on the functionality on how often, who, or where a function can take place. Also, to represent here, we have the black box testing. So it's an input, it goes through the black box and have the output. So the non-functional testing includes performance, load, stress, usability, accessibility, maintainability, reliability, and portability. So the next is structural testing. It's a testing that takes into account the internal mechanisms, the structure of a system or component. Types include branch testing, path testing, statement testing. So to represent, we have the white box testing here. So you have an input and then you will be able to see the code and how the system is developed internally, and then you get the output. So we call it white box testing. So structural testing, known as white box testing, it is sometimes called glass box as well. Usually follows a specification-based test to ensure throughout layers of coverage. Full structure testing is very thorough. but time-consuming, and it's often mandated in safety-critical systems such as life support machines. Coverage measurement applies at all levels, as any aspect of a system which can be represented in structural diagram can be used as the basis for structural testing. So program code design, coverage of statement, decisions and path, component hierarchy diagram, coverage of component interfaces, and web pages structure, coverage of page navigation. Change-related testing. Testing a system following modification or corrections. Include retesting and regression testing. This is testing following a change or fix to the software or environment. This should involve two types of test: retesting and regression testing. So retesting is just a confirmation of a rerun or a fix that developer has done. So within this context here, this example, so let's say this remember me is broken, and then you raise as a bug, and the developer fix it. Then the developer refer back to you as a tester, and then the tester go and retest and close the bug. And after this is fixed and the developer releases all this feature here, everything, then you have to do a regression test. The regression test is just to test a previous program that has been working, but there's no other problems due to one bug or one defect that has maybe introduced other defects around the area. So an estimated 20 to 50% of changes introduce new defects. So it's always important to do regression tests prior to release the software. It may be performed at all test levels and types, include functional, non-functional, and structural testing. Regression should take place at all stages of testing after a functional improvement or repair has been done. So in most places, the companies, the development team runs an automation testing. This is an advanced level for the new testers. So make sure you follow my blog for other courses specific in automations. I'll be sharing some more things. So retesting and regression tests should be, repeatable, so they can rerun every time there is a change or fix. So for in a goal to save time, the automation can be an essential part of these key areas of change-related testing. So even though automation is great, it's not a full substitute to manual testing, as not 100% automation test can be achieved, and it shouldn't be achieved. What is maintenance testing? Once the software is deployed, the system can go running, for years or even decades. So during this time, the operational system, the configuration data, or the environment, often there is some corrections. They can be changed or can be extended. So the testing of these changes is called maintenance testing, and it's triggered by planned enhancements or upgrade to business systems, corrective and emergency changes, changes to the operational operating environment, such as system upgrades, upgrade of commercial off-the-shelf software, migration of applications from one platform to another, retirement of legacy software systems. So in this graphic here, we're representing, the live system. Within the live system, there will be some new changes that you need to investigate, and you need to assess the impact, the changes, the risks. And within this live system, you select some key functionalities that you will include in your regression test pack. We talked about regression tests previously. and that's how we classed as maintenance testing. Okay, this is a review of what you learned on this section. So this is the end of the section 2. So far, we talked about a waterfall model, V model, iterative model, the agile type methodology. We talked about unit or component testing, integration testing, system testing. Talked about acceptance testing, also called UAT, what it means functional testing, non-functional testing, structural testing, change relate testing, and finally the maintenance testing. So if you need to refresh your memory, just go back, revert back to the videos and look to that specific area. And we now complete this section 2. Well done. Okay, first of all, I want to say well done. So you complete the second section. So the first one is done, now the second one. So don't forget to use the quiz down below. The quiz is important so you can fix what you learn on about this section on your memory. Again, if you have any questions, send me questions throughout the platform, or send me contact down below. I will be answering as soon as I can questions related to this section. And also, if you have any comments, how this can help you, or these help you as well. So if you have any criticism, please help me. I think it's everything is a learning progress, and it will help immensely. Thank you. And if you really, really like it, thumbs up and share with your friends, share with your colleagues, or people who you may think will be benefit from these as much as I did, and I hope you will do as well, and you will pass on the exam. Okay, so I want to say again, thank you.